Lesson 2 of Chapter 0, Part B, we're going to talk about some more operations with complex numbers. To review, first of all, we discussed the imaginary unit I. It is equal to the square root of -1. And I squared is equal to -1. I to the third is equal to -I. And I to the fourth is equal to +1. So we use that for simplification purposes. We also talked about adding, subtracting, and multiplying complex numbers. A complex number is a number in the form a plus bi that has two parts to it, the real number part, a, and the imaginary number part, b. So today we're going to talk about multiplying and dividing complex numbers. Now, when you see a binomial, and a binomial is simply an expression that has two terms. So this binomial is squared, and so it might be helpful for you to rewrite it as two binomials written side by side. Then you can use the FOIL method to multiply them. So the first terms, 1 times 1, outside terms, 1 times 4i, inside terms, 4i times 1, last terms, 4i times 4i. And then after you FOIL it, you need to simplify it. So the middle two terms combine to give us an 8i. And then the last term, we can change that 16i squared into a -16 because I squared is equal to -1. This would then simplify into -15 plus 8i. And there is your simplified complex number after FOILing that binomial. So next we want to get into division. Now if it's written horizontally like this, it's helpful to rewrite it in a vertical fashion. So what you're going to need to do to simplify this is you need to eliminate the imaginary unit from the denominator. So the best way to do that is what I call the ancient Chinese secret, and that's multiplying by 1. Because when you multiply by 1, you don't change its value. However, we're going to use the conjugate of the denominator to help simplify this. You can see we have 1 plus 2i over 1 plus 2i. That expression is equal to 1, so we're not changing the value. And the reason we chose 1 plus 2i is because it's the conjugate of the denominator. So now I'm going to FOIL the numerator. And when I FOIL the denominator, normally I don't write out all 4 terms, but I'm going to do that here so that you can see what happens with those middle 2 terms. So when you FOIL out conjugates, the middle 2 terms should cancel out, as you can see here. So simplifying, we end up getting 1 plus 4 on the bottom, which is a 5. In the top, it looks like we can change that into 5 plus 7i plus 6, which reduces into 11 plus 7i. And this is how I would write the answer. However, if you'd prefer, you could separate, and you could rewrite this as 11/5 plus 7/5 I. Those two answers are equivalent, they're just written in a slightly different manner. So that is called rationalizing the complex expression from the denominator and involving division. You're going to have some of these problems to do. Here's 4 of the division problems that I'm going to have you simplify, and then when you're done with that, some additional multiplying.